Hello, dear friends and learners. It's Dr. Bhatt here. Today, we have to learn about electrolysis and electrolytic dissociation. We shall also have an idea about products of dissociation due to electrolysis. Certain products are formed on conducting electric current through an electrolyte. So let us start. But before we take up electrolytic dissociation, we need to recall what are electrolytes. And then we shall get an idea about Arrhenius theory of ionization. And therefore, I'll repeat that electrolytes are the substances, mostly inorganic substances, which conduct electricity and are decomposed by passage of the electric current. These happens in their molten state or in dilute solutions. By dilute solution we mean normally for inorganic substances the solvent is water. So the substance which dissolves in water conducts electricity, or it may be in the molten state or in the fused state. Molten or fused state means above the melting point or at the melting point. So I repeat again that electrolytes are the substances which allow the passage of electric current and are decomposed thereby, forming certain products. Now, why this happens and what are the products obtained, we are now going to take it up. There has been a theory of ionization given by Savante Arrhenius in the year 1884, which gives us an idea about what is ionization and ionic equilibria and what are the products, how can you get it. So we have to go through Arrhenius theory of electric dissociation or Arrhenius theory of ionization. It's all the same. Now, there are certain points which we need to learn about Arrhenius theory of electrolytic ionization. And that is point-wise, acid, bases and salts when dissolved in water or diluted yield charged particles called ions. Charged particles means those particles which carry charge over them. Okay. It may be a positive charge, that it may be a negative charge. The positively charged ions are known as cations, whereas the negatively charged ions are known as anions. Cations and anions are the two parts which are obtained or which are given out in dilute solution of a salt. It may be an acid, it may be a base. Ions, but simultaneously what happens that as soon as the ions are formed, they constantly reunite to form molecules. Means there is a reverse reaction, reverse interaction we can say. The process of formation of the ions is known as ionization. And since it is a reverse reaction or reverse process, it has to attain an equilibrium state after some time between ionized and the unionized molecule. A equilibrium state is developed or established. Such an equilibria is termed as ionic equilibria. Now we can represent it taking AB as the molecule which on ionization forms a positive charge A plus and negatively charged ion B minus. A plus is cation, B minus is anion. So at equilibria, it happens like this. AB given out A plus B minus in a reversible equation. And since an equilibrium has been established, therefore like other reactions at equilibrium state, we can write down the ionization constant or the equilibrium constant. Like this, A plus, active mass of A plus, or the concentration of cation into concentration of anion. It is represented in terms of active masses upon the concentration or the active mass of unionized molecule. It will be equal to a constant at equilibrium state, and that is of course known as equilibrium constant. But since it is an ionization reaction, we call it as ionization constant and represented by Ki. Here are certain examples representing ionization. It may be a silver nitrate salt or a copper sulfate salt, or it may be sulfuric acid. When dissolved in water, it forms silver ion and nitrate ion, copper ion and sulfate ion, and hydrogen ion and sulfate ion, respectively. Now, what happens when we pass electric current through it? Now, when an electric current is passed through an electrolyte, the positively charged ions move towards the negative electrode. Positively charged ion means cations. Cations move to the negative electrode, that is known as cathode. We can, for our learning, we can say the cat goes to cat, and contrarily, ion goes to ion, and ion moves towards the anode. Now, therefore, we can say that ions act as carriers of electricity. They came in contact with the cathode. Negatively, ion comes in contact with the positive electrode, cat to cat, and anion, and they give up their charge. Therefore, this way the electric circuit is complete, and when the charge is given out, it becomes an atom and it gets deposited, or if it is a gas, it gets liberated at the electrode, respective electrode, maybe a cathode or anode. Now, let us see, here is a chart representing electrolytic tank, means a vessel in which electrolysis is carried out is known as electrolytic tank. We have taken a simple example of sodium chloride in a fused state. When sodium chloride is taken in the fused state, means at melting point, it forms Na ion and the chloride ion. Here is a cathode and anode. Now, these ions which are formed here would be sodium ion and the chloride ion. All sodium ions are directed towards the negative electrode. Sodium plus moves through the negative electrode, and chloride ion moves towards the positive electrode. Now, therefore, when they come in contact with the oppositely charged electrode, they give up their charge and get deposited over there. Sodium gets deposited over sodium cathode, and chlorine over anode. So that's there. Now this happens with almost all the salts in the fused state. Of course, I have given you two illustrations here. Electrolysis of water. Water ionizes to form hydrogen ion and oxygen ion in different compartments, cathode and anode. Negative is cathode, positive is anode. And this process of electrolytic decomposition has been utilized in designing a particular cell which is known as a fuel cell. We shall get into all details about the fuel cell sometime later in a different video. But even then, here we need to have understand that electrolysis results into the formation of a fuel cell. We use hydrogen and oxygen here to generate heat, which is converted into electricity, and using suitable electrolyte, having a membrane over here. Okay, then certain other details we shall get it in some other video. Okay, then we need to understand products of electrolysis. What are the products which will be obtained? What substance will be deposited by the electrolysis? Now, I have already made it clear that ions get discharged when they come in contact with the opposite electrode. Cations are deposited at cathode, and normally what happens that all the time we are not using a electrolyte having one single ion. Of course, when it is in a fused state like sodium chloride, there will be a sodium ion and the chloride ion, and chloride ion will move to the anode and sodium ion to cathode, and they will get deposited separately and liberated as chlorine gas and sodium atom. But normally what happens that an electrolytic solution is used, solution in water. Then water, it is known to us, water itself gets ionized, forms hydrogen ion and the hydroxyl ion, H plus OH, hydroxyl ion and the hydrogen ion. Now, electrolyte has also decomposed. Therefore, there are more than one ion present in the electrolytic solution. Now, in this case, what will happen? There would be a competition between the two cations and a competition between the anions to move towards the opposite electrodes. Now, here, one which has got lowest discharge potential, or what we call as deposition potential, or discharge first move towards the cathode and get separated. Now, this is according to the increasing order, lowest in the electrochemical series ECS, electrode chemical series, that deposits first. And here there is some increasing order of deposition potential of some of the ions are given here. Like lithium is minimum. It will get deposited first. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, nickel, hydrogen, copper, and mercuric, silver, and gold. These are the few common cations which will be deposited in the electrolytic series according to this order. And as for anions, the increasing order is like this: sulfate, nitrate, hydroxyl ion, chloride ion, bromide, and iodide. Well, this is just a representation and understanding of the making products of electrolysis, which is inferred according to the preferential discharge theory of ions. And according to preferential discharge theory, such ions possess lowest discharge potential, are positioned lower in the electrochemical series. Well, that is there, and we have an idea about electrochemical series. Now, next, since there may be more than one cation or the anion present in the aqueous solution of sodium hydroxide, sodium chloride, copper sulfate, sulfuric acid, dilute nitric acid, and silver nitrate, etc. So, what would be the products of reaction and what would be the reaction occurring at anode and cathode? We need to understand. Well, there is one more point that has to be considered. That is the type of electrode. It may be inert electrode like platinum and graphite. They won't react with the cation. The cation will be discharged and would be deposited there. But there might be a reaction at the electrode itself. Suppose we use a copper electrode using copper sulfate solution, then copper will be oxidized to copper ion and you may get copper sulfate deposited over there if it is a sulfate ion is there. So, well, that will be at the cost of copper electrode being used up. Well, these are a few electrolytic products of decomposition given over here. Mostly it is oxygen, chlorine, and in certain cases where a active electrode like copper electrode is used, it may undergo reaction. Well, there is one more point about concentrated sulfuric acid. When we use concentrated sulfuric acid using platinum electrode, we get what is known as peroxidized sulfuric acid, H2S2O8. Well, These are the reactions which would be of much help to our students who have learned about electrolysis and electrolytic dissociation. Well, here I will not hesitate to point out that this is not the end. There is one more point to be considered, and that is regarding the quantity of the products obtained. And that quantity of the products which are obtained are deposited at the electrode and cathode, anode or cathode. It is governed by a law which is known as Faraday's laws of electrolysis. We need to go through Faraday's laws of electrolysis. There are two laws which have already been presented to our viewers and learners through a short video. I therefore request all our viewers and learners to go through the short video which I have already presented on YouTube. Thank you very much, and we shall be back again with some more details on certain other topic. Okay, thank you. We stop here.